This presentation deals with the specification of maxon spindle drives. How must the parameters in the catalog be interpreted? As an example, we take the catalog page of the GP32S ball screw version. As with all other maxon gearheads, there can be more than one product in a column. Each product starts with its order number, followed by the reduction ratio of the gearhead. But what interests in the end are the mechanical power limitations of the linear motion of the nut. Maximum feed forces and feed velocity is what is needed for the selection. What we can see from the numbers is the higher the gearhead reduction, the higher the possible force, here up to a maximum force of 2700 Newton. At the same time, the maximum velocity becomes smaller and smaller. Essentially, these continuous and intermittent feed forces and velocities, as well as temperature and radial forces, stem from life expectancy consideration of the components: gearhead, nut, bearing and lubricant. More about this a little bit later. On top, one finds information about the screw type, the nut and the gearhead. The lower part of the spindle drive datasheet shows parameters that are mainly depending on the number of gearhead stages used. An important one is the overall efficiency. It depends on the number of gearhead stages and the screw type used. It's highest on ball screws. Another parameter is the mechanical positioning accuracy. More about this a little bit later as well. The bottom of the page shows the maxon modular system with possible motor and sensor combinations. This list is continued on the catalog pages of the other spindle drive based on the same gearhead diameter. We return to the maximum feed forces. As mentioned already, they are related to life expectancy considerations and are given for maximum gearhead output speed. In spindle drive, these feed forces may stem from different origins, from gearhead torque limitations, from actual bearing load limitations, from actual forces on the nut. As a rule, the gearhead torque, the actual bearing, are not the force limiting factor. Most of the time, it's the maximum force on the nut screw contact. It is calculated from life expectancy consideration taking into account the maximum gearhead output speed. Remark: for very low gearhead reduction, it is often the motor torque that limits the feed force of the whole unit. A last limitation may stem from the maximum actual compression force of the screw. For very long screws, the screw can start to bend and buckle. An additional support at the screw end can help to avoid this. This excerpt from the spindle data explanation shows that essentially the same limits apply to feed forces as with gearhead torques. Intermittent operation at high forces should not exceed 1 second. High loads must not be applied during more than 10% of operation. The catalog data suggests that the operating ranges of spindles as well as of gearheads look very simple. They can be represented as rectangular fields in the velocity versus force diagram. Experiences and life testing experiments show, however, that spindle life is essentially a matter of the mechanical power transmitted. A line of constant power corresponds to a line of constant life. Exceeding this power will reduce the expected life. Staying below this power results in a higher life. This revised operating range diagram also shows that higher feed forces and velocities are possible as long as the power remains sufficiently low. It's all a question of gaining or losing life, and at some rather high forces, a question of mechanical destruction. The speed limit can stem from maximum speed of the ball return systems of the spindle nut. This is particularly important for high rotational speeds of the screw, as can occur on low gearhead reduction ratios. Or, high speed limit can stem from the maximum speed of the spindle due to resonance oscillation. They depend on the runout and the length of the spindle, particularly important on long and thin screws. But most of the time, it's the maximum input speed of the gear that limits the linear feed velocity. The diagram shows that the screw rotational speed is higher than 1000 rpm only with one-stage gearheads. And correspondingly, for most gearhead reductions, the feed velocities are low. For example, a screw speed of 1000 rpm with a pitch of 2 mm results in a feed velocity of only 32 mm per second. The mechanical position accuracy has three major contributions. The general tolerance of the screw. The tolerance class of our ball screw supplier is C5 or IT5. It is about 20 to 30 microns for our standard spindle length. This is an absolute tolerance and has no influence on repeatability. The second contribution is the backlash of the gearhead, typically adding another 10 microns. The last contribution stems from the actual play of the nut. Preloading the nut can improve the repeatability, but zero play is not possible due to the gearhead backlash. Comparing the position accuracy parameters in the catalog, one remarks very large values on the metric spindles of GP8S and GP16S. These values are based on worst-case consideration and reflect mainly the tolerance class of the screws. Repeatability is much better. I hope this presentation helps you understand the meaning of the most important maxon spindle drive parameters.